Good day, everyone, and welcome to our webinar, Performance Testing on Sterile Barrier Packaging Systems. I'm Anneke Willems, and I'll be your moderator today. Before we begin, we have just a few brief announcements. First, this webinar is designed to be interactive. In the right bottom of the screen, you have the opportunity to click either chat or Q&A. If you are experiencing any technical problems, please use the chat function so we can do our best to assist you. But if you would like to ask a question on the content of the presentation, we would like to ask you to use the Q&A function. You can check a box there to make sure that your question is asked anonymously if you would prefer that. And now let's go on to the presentation. Discussing today's topics are Tommy Smith, Technical Leader in the EMEA region. He is based in Ireland. And Jeremy Elwell, Senior Principal Engineer based in Grand Rapids, Michigan in the USA. I will now turn it over to Tommy to begin.
Thank you, Anneke. Good afternoon, everybody. I hope you're all keeping very well. As Anneke said, my name is Tommy Smith. I'm the Technical Leader in the EMEA region. I'm located in Oramore, County Galway in Ireland, where we have our technical centre. I come to you today with 10 years experience in the medical flexible packaging industry. I've previous experience with Steripack and Bemis Healthcare Packaging. In terms of education, I have a degree in polymer science and polymer engineering and a PhD as well in polymer engineering.
Hello, everybody. This is Jeremy Elwell from Oliver, and yes, I'm in Michigan, United States. And like Tommy, I have experience in medical packaging of about 13 years in different types of roles. I have prior experience at Stryker and Benson Medical, which is a contract manufacturer. So I've had roles in packaging process engineering, packaging design, and test lab management. And I also have a degree in packaging from Michigan State University.
Thanks, Jeremy. Yeah, so today, just to kind of give you a top level of what we're going to talk about. So initially, we'll be talking about performance testing, and we'll give you an overview of what that looks like in terms of, from the very concept right through into, post-performance testing. And we'll look at potential defects that we have seen in the past. And we'll also talk through some solutions for those defects. Then finally, we'll have some key takeaways of what we find, is most important from the webinar, and then we'll have some questions and answers. So let's begin with the performance testing overview. So performance testing, I suppose, what is it? So it's called, depending on where you're located or depending on what company you work in, it can be called transit testing, distribution testing, package and design verification. But basically what it is it's a sequence of tests that you put your final packaging through in order to stress, to apply as much stress on them as possible, in order to basically ensure that throughout the distribution of that product and packaging, that you will ensure that your product will actually meet form, fit and function and pass. So 11607 is a voluntary standard. So the standard itself has two parts. It's got part 1 and part 2. So part 1 focuses on the packaging system performance and stability, while part 2 focuses more on the process validation and process verification. So for today's webinar, we'll focus on part 1 and specifically on section 8. So the performance focuses on distribution testing, transportation simulation, while stability involves kind of accelerated aging. So this basically means that you're subjecting your samples to distribution simulation, and then you test the sterile integrity, such as bubble leak or dye penetration, following the schedule. So there's some kind of key highlights we've highlighted from section 8 of this 11607 standard. And the first one I've just mentioned is the integrity testing. So following the schedule, you will execute bubble leak or dye penetration testing to ensure that the primary package that you've selected meets your specific requirements. It's also important to note that when you're doing your packaging simulation testing, performance testing, that you have adequate protection to the product through the hazards in order to ensure that during the hazards that it has the best opportunity to pass. And then finally, when you're doing your performance testing, you need to consider working on the worst case scenario. So the worst case sterile barrier system and worst case packaging. And Jeremy, I know you have got some real good experience on this, so I think the next slide, if you would mind taking it.
Yeah, thanks, Tommy. So for the worst case considerations here, so in my experience, I like to start with defining the device and product family itself. So you have to confirm the similarities of devices and packaging configuration. And for example, on this, there are times where a device may have the same description as another, but they could be a completely different uh, type, like a different type of plastic, maybe a hard versus soft. And you really want to pay attention not only to the description and how they're used, but the profile and all the characteristics of the devices to define that family. And then out of that family, you're allowed to select a worst case device and packaging configuration to represent that entire family in this testing sequence we're going to go through in this webinar. You know, and you want to consider the risks there, the heaviest, sharpest, largest, et cetera. You know, you sit through a risk assessment, and that's something we'll talk about a lot during this webinar is the risk assessment. A lot of this is based on risk, the decisions you make, and this is one of them for worst case. Also for the sealing process parameters, so when you're sealing your packaging, whether it's a pouch or a tray, you do want to consider the worst case sealing process parameters for this performance testing. And that could be, and usually is, your OQ low settings, but sometimes it may be the nominal or high depending on what kind of parameter set you have in the output. So you want to check your process validation and determine what settings to run at for this. And also, lastly, is sterilization. In ISO 11607, it indicates to use the specified sterilization processes. And this is another place where you want to go through risk. Do you want to go, for example, 2 times ethylene oxide sterilization? Do you want to go a little bit higher dose of a gamma cycle? That's all up to you. You want to look at the standard and go through your risk assessment to see what's appropriate for this testing.
Okay, so I suppose it comes back to the question, you know, why do performance testing? Well, as we mentioned earlier, you know, the package selected needs to be subjected to the kind of stresses of distribution. So we need to ensure that the primary package meets form, fit, and function. And given with the MDR revisions of late, you know, maintaining the sterile until the point of use, and potentially, now this isn't actually in any documentation yet, but potentially without protection of a shelf life or a shipping carton is also important. And as I said, it's not in any regulatory documentation as of yet, but I think the below pictures give an illustration. And maybe Jeremy, do you want to talk us through those?
Yeah, Tommy. So the bottom left picture is a good example of a common central supply room in a hospital. So a lot of the times packaging engineers that design packaging, or anybody working at a medical device company, maybe doesn't always have the good view of what's happening in the hospital. And this is a good view of, sometimes the packages, like Tommy, you mentioned, are taken out of boxes. So maybe the shipper, you see some shippers there, but some are just in bags and, all over the place kind of. So you want to make sure you're designing packaging. So like Tommy, you said, can give that protection without the shelf or shipping carton. And in the middle there, you can see, rubber bands too. You could use rubber bands, and while you're not intending to do that, maybe you have a pack of 10 in a box that are nicely packaged. They could take those packages out of that box and use a rubber band. So something you want to consider the handling after it in the hospital like this. And finally, on the right are a couple healthcare practitioners that they will take from the central supply room and put on a cart and take around the hospital, whether it's to the operating room or other places for storage. You have to consider these packages could fall off a cart while in transit too. So these are all things that, as the industry trends this direction, we're paying more attention to this final mile, as we call it in the United States, but also just the final steps of the process before the devices are used.
Yeah, it's interesting, Jeremy, because I suppose when the MDM, when they pack their product and they're, maybe some of them assume that that the storage in these in the end user is plentiful as it is in theirs, but it's these images are fairly obvious that in some cases that's not the case. So yeah, it's very interesting. So just to talk you through the sequence of events, so as Jeremy just spoke about, initially when you do performance testing, you obviously need to have a detailed plan, a good protocol in place, and that protocol is obviously risk-based, so you obviously carry out a risk assessment, and you define your worst case, and you define everything you're going to do from the transportation, the samples, how many samples you're going to do. You're going to select your sterilization. As Jeremy said, you're going to, select your dosage of whether it be ETO or be gamma sterilization or E-beam. And then you will then, following your plan, and obviously on a roundtable committee within your organization, you'll have agreement on that. You'll move in then to your selected conditioning parameters and your performance testing cycles that you've selected. And then finally, you'll finish up, as I said earlier, is with the integrity testing post the performance testing.
Thanks, Tommy. And one point I know we left out of that is a very important note from 11607 Part 1. This is a note about stability testing, or otherwise known as aging studies, whether it be accelerated or real time. In 8.1 here, the underlined area you can see is separate entities. So stability testing and performance testing are separate entities. So from a regulatory and standard perspective, we want to keep those separate. So everything in this webinar is going to be solely about performance testing, while aging really isn't intended to go through these same sequence of events. So that's something very important to keep in mind.
Yeah, thanks, Jeremy. So, as we said, once you've defined the plan and you have your worst case selected, you have your samples built, you have your sterilization completed, the first step is climate conditioning. And you might ask, well, why have I to do climate conditioning? It sounds a bit extreme, but obviously in the environment that the product is manufactured and converted, that may not always necessarily be the same as where it's going to end up. So you need to ensure that no matter what condition or environment it is in, that it's going to pass. So you need to subject the product and the packaging to various different conditions, and whether it be frozen, warm and humid, and dry heat, or sorry, high heat and dry as well. So maybe, Jeremy, do you want to maybe talk us through the standards a little on this one?
Yeah, Tommy. So we have two standards that are listed here, and these are two typical standards. They're not the only standards, but these are recognized in ISO 11607 Part 1 as standards you can use for this step of climatic conditioning. And I see a question come in. Climatic conditioning and aging are separate. Climatic conditioning is really simulating shipping, like Tommy just said, through these different environments. So quick shipments, from a day to 3 days is usually what we're looking at. And that's opposed to aging studies that are much longer. So these standards, provide flexibility. So ASTM F2825 really is kind of a short-term parcel shipment that goes through these cycles pretty quickly, around 8 hours. And then D4332 actually is longer term. So depending on what you want to do and where you think the channels are going to be of shipping, you want to take into consideration using these standards for your testing sequence.
Okay, so the next slide here talks about the performance testing overview. So we've talked about the conditioning now. So now you can take that the conditioning is being completed. So now you really need to go into the performance testing and what that involves. And there is a variety of different ways you can go about doing this. And again, it goes back to your protocol. It goes back to your risk-based approach. But just to give you some examples, you're talking about testing like the likes of vibration, whether it be in truck or in air. You'd have vehicle stacking, so you want to basically ensure that the pallet size and the pallet height, and that the bottom carton doesn't get damaged because of the weight. And then finally, you could look at testing such as altitude testing, so obviously being airborne. And again, there's obviously standards around this. Jeremy, because you're the guru on the standards, do you want to take us through them as well?
Yeah, Tommy. So we have a couple standards listed here. We have ASTM D4169 and ISTA 3A, and these are both recognized in 11607 Part 1. They are very commonly used around the world. I'd say my experience, D4169 is starting to trend up as being more commonly used. However, ISTA is very common as well. What we're going to be showing you in a video on the next slide is ASTM D4169 and some of the steps that we've talked about. The distribution cycle listed here is distribution cycle 13. So if you look inside of that standard, there's multiple distribution cycles in there. And DC 13 is the one that is selected for medical devices through the industry. So it's one of the more rigorous, and it is challenging the packaging more than the other distribution cycles. So it really matches what these are being shipped at. And the assurance level 2 that we have listed there is very important. And there's 3 assurance levels. The assurance level 2 is the most common, and the standard actually directs you to use that unless otherwise stated in your risk assessment. So assurance level 1 will actually provide a higher level of intensity to your package, while assurance level 2 is a lower level of intensity. So considerations like risk level and unknowns, you may want to go to assurance level 1 and heighten your intensity a little bit. But on the other hand, if you know a lot about your packaging and you have a lot of testing and it's a lightweight, low risk device, maybe a class 1 device, you could consider doing assurance level 3. But of course, just like everything else, you want to have that justification documented. So I believe now we'll go to a video showing some of these steps that we've gone over.
Yeah, so I suppose this video is kind of going to lay out exactly, it kind of gives a good visual. So the first part, obviously, as we discussed, is the climate conditioning. So again, as per the ASTM D4332 or the ASTM F2 AS25, the operator here is, as you can see, he's placing the shipper cartons into the conditioning chamber, and them shipper cartons are going to be then ran through those temperatures and humidities. The next one here is the drop testing. So this is where the actual shipper carton is dropped in different sequences. So the edges, the corners, and each side is dropped at the specific height as set out in the standard. So again, you're just ensuring that the shipper carton meets form, fit, and function.
And Tommy, furthermore here, the next step, as you mentioned, the compression area. So this is where we're simulating vehicle stacking. So the compression really is based on the size of the box, density, truck height, things like that, to ensure that it can withstand that stacking. And then the next step, the transit test part, the bread and butter here, the vibration table, where packages are submitted to this table to simulate truck shipment, air shipment, ocean shipment, different sine waves and vibration cycles. And then finally, this is an impact test, and a dart drop test that is simulating any kind of impact or sudden burst of energy to the side of the package. And so after that video, that's the sequence of events to condition through the simulated shipping environment. And as Tommy mentioned earlier in the intro, is that we're performing integrity testing after that. So the first video you're seeing is a bubble leak test. This is based off of ASTM F2096. And what this is a whole package integrity test. So you're submerging the package underwater, filling it with air, and looking for a constant stream of bubbles, as you saw in the video. The sensitivity of this is down to 250 micron. So if you have any pinholes after that, this is one of the most important parts. You're putting it through all the shipping, you see it dropping, vibrating. You really can test to see if any kind of pinhole or sterile barrier breach has occurred in this step.
Yeah, and the next integrity test obviously is the dye penetration test, which I'm sure a lot of you are aware of, and a lot of you probably perform on a regular basis. So it's tested as per the standard ASTM F1928. It has a sensitivity of 50 micron. And basically what you're doing here is you're actually ensuring that the seal integrity is intact as it was before you started the conditioning. And here you can see we've actually put a void into the seal in order to give you an idea of what that looks like. If you did have a channel in your seal.
So next we're going to go through some potential sterile barrier defects. As you saw, the integrity testing, that's what we're looking for. So we're going to go through what could happen to your packaging. So Tommy, do you want to walk us through some of the most common?
Yeah, thanks, Jeremy. Yeah, I think from kind of our previous experience, we've highlighted these 4 potential defects. The reason being is, there are 4 that are quite popular that can happen, and you can see, from time to time, obviously depending on the product, depending on the packaging that you've selected. So the first one, actually, we're going to talk about is flex crack, I believe. So Jeremy, would you mind taking us through flex crack?
Sure, Tommy. In flex cracking, the one I like to go over first because sometimes it's not considered right away. Sometimes it's not a very well-known type of defect. So first of all, what is flex cracking? So flex cracking is the loss of barrier and or mechanical performance of a material after repeated flexing, most commonly during vibration cycles. So as you can see in this simulation we have here in the video, we cut open a window in the side of a shipping box, and that shipping box is, on the vibration table, causing these boxes that they're not, and the packages to bounce around if they're not properly held down. So on the left of the video, you can see this film kind of turning white. So if you picture it repeatedly flexing over and over again on the same spot, it could start to turn white, and then eventually in the bottom left-hand corner could turn into a through hole or a pinhole. It doesn't happen every time, but this is a risk that we want to talk about. And on the next slide, this is a way that we perform testing on films to test for flex durability. This is called a Galvo Flex Tester, and this is per ASTM F392. And we're taking a sheet of plastic and flexing it 2,700 times over and over, letting it sit for about an hour to see, to do that conditioning that would simulate what's going to happen in that vibration environment. And on the next slide, after that is flexed in that Galvo Flex Tester, we put the film down on a piece of white paper and apply. This is the same dye that's used in the dye penetration test that Tommy has mentioned. So we let it sit for an established amount of time, and then you wipe off the excess dye as you see in the video. Now what remains are little blue dots on that piece of paper in the background, and those dots really indicate how many pinholes are in that sample. Now there's really no acceptance criteria in the standard to say, here's what's good, here's what's bad. This is more of a comparison. So on the next slide, we have the results of this test. And as you can see on the bottom of this slide on the left-hand side, you can see the high amount of pinholes that are present in this 92 gauge polyester. This area, 85, 77 pinholes, that's an average of about 80 pinholes on that test. And you can picture that 8.5 by 11 inch our standard piece of paper for printing, that has about 80 pinholes. That's quite a bit. And if you look on the left of that in the same graph, that 48 gauge is a little bit thinner gauge polyester, but it has about half as much. So the message here is really thicker isn't always better. So sometimes when you have your solutions, you say, I have this hole or this pinhole in my package, and what can I do to fix this? Maybe you're in a test environment. The good solutions maybe could be at the top there are changing the packaging dimensions for a better fit, allowing more space for your device to fit without any kind of stresses. Don't overpackage. Also, you can change the pouch material, but thicker doesn't always mean better. So if you have a polyester and you have the 48 gauge and you have some pinholes, say, okay, maybe I want to go to a thicker material and that would be better. Actually, if you go thicker with polyester, you could actually end up with more pinholes from this flex durability testing. So changing pouch material is an option. On the right, we have nylon. So this is 60 gauge nylon. And in that same test, we actually, in our simulated environment, it came up with 0 pinholes. So it really has the 60 gauge nylon and also 100 gauge nylon. Has a few, but not as many as polyester. So really the circled area is our prime candidate for this. If you have a concern about flex cracking, the 60 gauge nylon is really the best performing material that we have in our catalog. But also nylon in general is better than polyester, but the message here is, again, thicker doesn't always mean better in this case. So Tommy, I covered flex cracking. Do you mind walking us through a little bit about the abrasion that we have highlighted here?
Yeah, sure. I will do, Jeremy. Yeah. So abrasion is obviously another defect. And again, this can occur when you have an area of your film that's kind of wrinkled, and it can come to a point, and that point can sometimes come up against, for instance, a shipping carton or a container during, for instance, the vibration test. So you can get actually scratches causing a defect in the surface of the film, which could actually eventually wear through, and it could actually cause a pinhole. You can see on the bottom left image there, it's the image is not 100 miles away from what the flex crack image looked like. So going back to what Jeremy said, and we're probably going to repeat this a few times, but you know the defects that you see in everyday life sometimes can look the same, but you really do need to do your full analysis. And basically you can see what's happening here is the actual product in the package. It appears that it's just not fit for function, in that the packaging is a lot larger than that of the product. So it's got a lot of movement in it, and it can cause basically that product to come up against the film and can cause this scratching. So some possible solutions to abrasion testing. Well, the first one is obviously to, I suppose, right size your packaging. Your packaging, so to ensure that you have the correct packaging for the product. What we've seen more often than not, and I don't know, Jeremy, I'm sure you have as well, especially in Europe and in the States, is that MDMs, they tend to, if they have a packaging configuration, so a top and bottom web, and they've been using it for quite a long time, they tend to want to reuse it again because they've got some good data on it and they've got some good information around it. So sometimes they can tend to say, no, we're going to stick with the packaging we have and we're going to work with that size. That's not always the best thing to do, because it's really dependent on the product that you have in that package, because that really drives what that material of the primary package should be. So I suppose you should be cautious when you're selecting the package for your actual product. Another kind of solution would be to minimize the movement in the package. As we've seen in the video, you can see that the product was moving quite freely around the actual package. So that is really not good, because over time that can cause an issue. And also smoother packaging surfaces would obviously improve things as well. So the next defect we see here is puncture. So, puncture resistance is a very common defect, and a lot of companies are very familiar with this. And this can be caused, for many reasons. And here you have another good image of what a puncture test looks like on a flexible film. And in this situation, you can see quite clearly that the area of the device appears to be sharp. So for instance, there could be some excess flash around the actual product, and that basically could be puncturing through the material. So when the package is undersized, like I said earlier, there can be a lot of unnecessary force on that particular point of the material. And it's this type of issue that can be seen in the simulation process. So for instance, especially in vibration testing. So this is a really good kind of slide, I think, and at least it gives a really good description of, Jeremy mentioned earlier when he was talking about flex crack, is that thicker is not always better, but that's for that situation. Now, if we look at puncture, obviously we have a nice graph which illustrates, a 48 gauge polyester PE. Then we have the graph showing the puncture resistance for a 92 gauge polyester PE, and then finally 100 gauge biaxially orientated nylon. And the graphs are actually showing both the sealing side and the outside of the material. And you can see here, it's very clear that with a 48 gauge polyester, your puncture resistance is anywhere between, 4 to 6 pounds of force. Whereas if you look at the 100 gauge nylon, you can see the puncture resistance here is significantly higher. So here, for instance, if you had an issue that was puncture, switching out a material could be the right thing to do in order to mitigate that risk that you have. That is really, really important. And then obviously, I'll go back to it again, is a change in pouch dimensions. So right sizing your package to fit the product. So these are, I suppose, just a brief summary of the three that we've discussed so far. You have the puncture resistance, the abrasion, and the flex crack. again, this is at microscope level, so they look even quite similar at microscope level. So even if you're looking at them through your naked eye, and you have them, we'll say, I don't know, a foot away from your eye, they're going to look incredibly similar. So it's really, really important that when you find an issue, or if you find an issue, that you really do your analysis before you actually go about making implementations and change, because you may think it's a puncture because it's a common feature, and a lot of people are very familiar with that type of an issue. However, it could actually, following the analysis of the package that has the issue, it could actually be, for instance, flex crack or abrasion. So I suppose the point is, be very mindful of the defect that you find, and do your root cause thoroughly, because by doing that, you will be able to overcome and select the right configuration or material next time. So the final one we're going to talk about here is seal creep. So maybe Jeremy, you might take us through that.
Yeah, thanks, Tommy. And so those three that Tommy covered, obviously, he summarized as kind of whole through the film or through the tieback there. And this one for seal creep is more on the seals. So in this video, we're simulating what may happen in a environment that with changing pressure, right? So this could be in an EO sterilization chamber or a high altitude shipment. In the package on the left, we have covered the porosity. This is Tyvek lid, but we've covered the porosity with the label that's blocking all the breathability and porosity. So the one on the right has full breathability, and you can see the one on the left start to inflate. So in your EO sterilization cycle or a high altitude shipment, this really is a common thing that can happen. The air inside the package wants to escape. And if you're blocking the porosity, it could happen and blow through your seal and cause a complete rupture of your seal. Now, this doesn't always mean it's going to happen fully. This is what we call seal creep. So you could have I apologize. I think I got cut off there. I'm back now. Sorry about that. So, yeah. Annika, if you can go to the next slide, just so I can talk a little bit about the seal creep. I think it's very important. So, again, the possible causes: change in pressure, low porosity, high altitude shipments. So again, on the right-hand side, we have that package that is inside of that high altitude shipment, showing that it could have an effect there. Exposure to vacuum and high temperature, EO sterilization chamber, like we talked about. Now, keep in mind, it's not only happening in here. So you could have also a tight device fit could stretch the seal. So if you're under packaging, if you're trying to really force a device into a package, it could stretch those seals in a way that looks the same as this. But also in this video that we can play at the bottom, the device can penetrate the seal. And this is the drop test that we showed earlier with a window into the shipper. And you can see that the device there has penetrated right through the seal. So just like Tommy mentioned earlier about different holes in the package, actually different types of seal creep could have different causes. So you really want to understand where this is coming from. And one of the most unknown places where people come to us and say, we have this failure, really we have them check the EO sterilization chamber first and say, are you blocking the porosity? So the possible solutions in the bottom right, at Oliver, we do have Tyvek coatings designed to reduce the risk of seal creep. So we have the coatings, the adhesives, like in this tray example on the right, the tray on the right could have a better resistant coating to that change in temperature and pressure and really allow for a stronger seal in that. But also, the key here is to limit the obstruction of the porosity. So if you have a Tyvek lid, you want to ensure that breathability is happening. We have, for example, a hot melt Tyvek coating. So very typical and common coatings, flood coated and cover the whole Tyvek area. Our hot melt coating is more of a dot pattern that allows more porosity. So, if you're interested in this, you can reach out to us. We can walk you through what the differences there. And also, a few key common aspects are label placement. As you can see, the label is, blocking the tray on the left that has that ultimate seal creep, but also shipper configuration. If you have a nice porous lid, but you're overpacking it into a shipper and blocking the porosity, that could cause some problems with seal creep as well. So now for, in summary, we have some key takeaways for you, then we'll go into Q&A. So a couple of the first part of the webinar, we covered, the test plan and what we're doing for conditioning and understanding the distribution channels and developing a test plan accordingly. Worst case justification is very key. Like I talked about, identifying the family and then selecting the worst case based on the risk. You want to choose the correct standard and assurance level and go through that standard and make sure that you're following the directions to pick the sequence that's right for you. Climatic conditions, again, different than aging. Climatic conditions are showing shipping through these different areas of the world, whether it be the frozen tundra or the desert or tropical conditions. And then, of course, doing the integrity testing to confirm that your sterile barrier is still intact.
Yeah, and I suppose just to kind of take the takeaways, Jeremy, from the understanding the root cause of the defects, as I said earlier, the defects might look quite similar when you actually are just looking at them through the naked eye, but when you do your analysis, you need to really, home in on what actually caused that. So, in-depth analysis, be both microscope analysis and some maybe analytical testing to see what exactly has caused this defect for you. So you really need to do that analysis, because it's only when you do that analysis that you can actually mitigate against it and select the right cause to prevent it from happening again. And then finally, then with seal creep, what caused it? Like you were saying, Jeremy, was it high impact? Was an incorrect placement of a label? Was it dropped? In terms of the seal creep, dropped at an angle. Was it forced out by the product? So all these things are really important to understand before you actually start your analysis, and then work forward from there. So that's pretty much the end of our webinar. We hope you enjoyed it, and we'd love to take some questions and answers from you now.
Yeah, as a reminder, you can still leave them in the Q&A section of this Zoom meeting. We already got one in that refers back to the integrity testing. There's a question: should you always do both the bubble leak and the dye penetration testing, or could you choose either one of those?
I think that's a great question. We covered the bubble leak, and Tommy, you can chime in here too with your opinion. Bubble leak and dye penetration were both covered back earlier in the slide deck, and really look at the sensitivity. So the difference between the bubble leak test is a whole package integrity. So you definitely want to do something to look at your whole package, right? So this goes down to a 250 micron level, and that's also checking the seals. So you are checking all of the film, all of the Tyvek, the tray, the lid, whatever you may have, plus the seals. But it is only going down to 250 micron level. So my recommendation after performance testing is to perform both, because the seal area, is more likely than the whole package to have a little channel, and that goes down to a 50 micron level. So that is the advantage of using dye penetration on the seals. You can find a smaller channel than through the bubble leak. So I suggest doing both.
Yeah, I'd agree with you, Jeremy, because given the time, and obviously the bubble leak is a more time-consuming test, but like, as you said, it looks at the whole package integrity, whereas the dye just looks at the seal. But, the seal or the dye penetration test is actually, it's a quick enough test. It doesn't really take that long to do. So in order, again, to mitigate against risk and to have a full evaluation when you're being going commercial, I definitely agree. It definitely would be wise to do both.
Okay, thank you for answering that. Another question that came in is, currently this company performs stability testing and performance testing on the same samples. Is that the correct way to go, or should you recommend that the samples be separated and complete separate testing on those?
So yeah, that's a great question. And if you currently do it, it may be tricky to separate the two. But again, in the standard 11607, it does allow for those to be tested separately. They're separate entities. So if you're starting from scratch, it's easy to say, okay, we'll do performance testing here and aging testing here on different sample sets. But if you're already doing it together, which in my experience, I came from a few companies that traditionally did them together. Now getting them to be separated, where, the industry, we're working on better standards and better ways to identify how to separate those two. But for now, yeah, it's going to be a little bit of a challenge doing that, but the recommendation is to trend that way. And we at Oliver, we have resources, and Tommy's the lead in the European Union, so we can help you with that approach and that strategy.
Yeah, absolutely. Yep.
Okay, thank you. One more that came in a lot of the graphs that you showed. It's said that nylon was almost always better. If that's the case, why wouldn't we always choose nylon instead of a PET film?
Well, yeah, I can take this one, Jeremy, if you want. It's really dependent on the project as a whole, because nylon, in terms of cost, it is more expensive, than the polyester. The polyester is certainly cheaper than the nylon, obviously depending on the thickness that you're actually going to go for. That's where you'll see some real price differences. But it goes back to nylon. Sometimes they are great for a lot of things. They have got, it really depends on the issue that's in hand. I wouldn't always say that nylon is always better than any other film. That wouldn't be the case. It's really dependent on the actual product that's going in there, and that the cycle and distribution cycle that you're actually going to use. So really dependent on the product and the life cycle.
Okay, yeah, that makes sense. And a question that came in, you talked about specified sterilization in the beginning of the presentation. I believe it was you, Jeremy. And somebody is wondering, you were talking about worst case for a lot of these testing. Does it mean that also needs to be sterilized at worst case, or can you just do a regular sterilization course there?
Yes, it's a very great question, and this is something that's kind of come up recently. I think the default, a lot of places will go to worst case and say, I do a 1x EO sterilization cycle, so for this testing, I'll do 2 times or 2x. Now, that's really up to your risk assessment, but if you look at the standard and the wording in there, it does say specified. So, I mean, if you want to put it through what you think the worst it will possibly see, I think that's the best place to go. So if you have a range in an EO sterilization chamber, and you usually run it nominal, but it could slip to like higher intensity of a vacuum cycle or temperature, you want to address that cycle itself and really know what it can see and put it through those parameters.
Okay, thanks. And there's one coming in here. There were a few standards on a few of the slides, and how do you choose the right standard sometimes? And linking to that, there were a lot of choices to be made. How do you sort of make those choices and assess all those risks? Is there anywhere you can get some help, or?
Yeah, I think really what it is it's really everything hinges off your risk assessment. So it's a risk-based approach. If it's an existing, we'll say product, but just is slightly tweaked, that you're using very similar packaging, well then potentially you could use the same cycles you used before. The standards are really guides. So for instance, with the conditioning, the ASTM F2825 and the ASTM D4322, they give you a guidance of what you should select. And they're not set in stone. It's at the end of the day up to you. You make the decision on what you want to set your conditions to. Again, that comes back to the ASTM D4169 standard, in that the schedule that you select, you can select, like we spoke about what we see as the most popular, which is Schedule 13, I believe, and Assurance Level 2, which is obviously the midpoint. But it really depends on what your product is. And is it a completely new product? Is it a heavy product? Do you want to give it like the bells and whistles when it comes to the testing, or are you actually familiar with it and happy to kind of go over what you've done before?
Okay, thank you. That makes sense. I see we're already at time, so I want to thank Tommy and Jeremy again for this presentation, and all of you listening for your attention and all the questions you send in. We might not have gotten to your question. We apologize for that, but you feel absolutely free to always contact us at our general email address or through our website. We'll be happy to answer your questions there. And I also want to conclude with the fact that we will send you the recording of this webinar afterwards, so you can rewatch it again and have all this information where you can reach out to us too. Once the webinar is closed, a short survey will pop up. We would like to ask you to fill that out so that we can improve our webinars and our service to you. Again, thank you for your attention.